So guess what you have to do first on number 4? If you said graph, good guesser. So graph it first. So what you'll need to note if you graphed yours using every square is 1, it'll look slightly different from mine. Mine is an enlarged view. I used every 2 squares as 1. But your coordinates should still be the same. So note this coordinate 2, 1 is one of the specific points it goes through, and 5, 2, and 5, -2, and 2, -1. Again, using the same strategy that I use on regular y equals x squared parabolas. I have a vertex. This is actually in HK form. Remember, H is always technically with x, and K is always with y. If I moved this back over, up here, that would be a -1. So H is 1, and inside K is 0. So that's why I have vertex at 1, 0, because my vertex is always HK. And then since my A value was 1 again, I'm going over 1, up 1, but this time I'm moving vertically, so I'm going over 1. I usually turn my paper sideways, or think of my paper turned sideways. So over 1 and then up 1. And then I go back and I go over 2 and up 4. Okay, so now the blue stuff is the area that I'm searching for. That's between all of the boundaries. And I noticed this time that my equations were actually in terms of y, and it's easier, thankfully, to find the region between the curve and the y-axis, since that's the stuff that I have shaded anyways. I'm not really interested between the curve and the x-axis. I'm interested in between the curve and the y-axis. So I'm going to be integrating with respect to y, and now instead of doing upper minus lower, it's going to be right, because right acts like the upper, minus the left, and left acts like the lower. Hey, think of that. L always comes second, left and lower. So now when I integrate, my rightmost curve is f of y, the purple one, and my leftmost curve is g of y, my orange one. And here's where, this is why I've been harping and harping and harping on you about the importance of making sure you have your correct notation so that we know which variable we're integrating with respect to. So now, if you turn your head so that the purple graph is actually the upper one, thinking in terms of x, and I look at the boundaries, the leftmost boundary, well, I sort of have to think of the graph backwards. I guess I would say the lowest boundary. So would be -1, and the upper bound for the curve, the shaded region, is +2. Okay, so I want you to pause the video, substitute in the equations, and see if you can integrate it all the way out. So the first thing I did was I substituted in f of y and g of y. Now I'm just going to simplify it. Looks like that. So when I integrate, now I've powered everything up. Now I'm going to substitute in my values. See if you can follow that all the way out. Okay, on to the next problem.